All right, welcome back, mathematicians. So now that we are familiar with Pythagorean theorem, now we're going to use what we've learned to find the distance between 2 points on a coordinate plane or on a graph. So here I have a graph. Let's do a quick review of what we have on our graph. So on our graph, we have what we call our origin. That's where my x-axis, remember your x-axis always goes from left to right. It's horizontal. And then you have your y-axis, which is vertical, which goes up and down. So you have your x and you have your y. And where those meet right here, we call that the origin, right? That would be at 0, 0. Okay, so our directions say graph and label each point A, B, and C shown on the card to the right. So here's our card, right? Here's our points A, B, and C. It says draw a triangle ABC and determine the length of each side and label each side with its measures. All right, so here's our points. I have point A, I have point B, and I have point C. So the first thing we need to do is we need to plot those points on our graph. So I'm going to put 3 dots on my graph where points A, B, and C belong. So let's look at point A. So point A says 0 and 4. Remember, when I'm reading my ordered pairs, I always have an x-axis and I have a y-axis. Okay, your x-axis always comes first and your y always comes afterwards, just like in the alphabet. X comes before y. Same thing with ordered pairs. My x value always comes before my y. So if I plot point A on my graph, I'm going to go to 0 on my x. So this would be 0, right? That's where x and y meet. So I'm not going to go to the right. I'm going to stay at 0. But then I need to go up to 4 on my y-axis. So if I'm at 0, I go up to 4. I'm going to put a dot right here. So this dot represents point A. I'll put an A there, which is 0, 4. So now let's do the same thing for point B. So point B is at 4, 4. Again, the first number is my x. The second number is my y. So I'm going to go to 4 on my x. I'm going to go up to 4 on my y. And I'm going to put a dot right there for point B, which is at 4, 4. Okay, now let's do the same thing for point C. So C has 4 for my x, 7 for my y. So I'm going to go over to 4 on my x-axis, go up to 7 on my y-axis, and I'm going to put a point right there. Let's go ahead and label that C. So here's my 3 points. Now I can connect these 3 points and create a right triangle, which is what I'm going to do with these lines over here. So I don't need to rearrange these lines. So if they're horizontal, they're going to stay horizontal. If they're vertical, they're going to stay vertical. If they're diagonal, they're going to stay diagonal. I don't need to rotate them at all. So I'm going to take this horizontal line and I'm going to use that to connect points A and B, right? So A and B, I use that horizontal line. Now let's use our vertical line and connect points B and C. All right, we've got B and C connected. Now let's connect A to C. So my diagonal goes up and to the right, so I'm going to use this diagonal piece right here, and we're going to connect A and C. So here's our right triangle. So if I look below, I've got the length of line AB. So here's AB. I have the length of line BC. Here's BC. And then I have the length of line AC. AC. All right. So for the first one, for the length of line AB, since AB is horizontal, since it goes from left to right, all I need to do is count the number of units it takes me to get from point A to point B. All right, so if I start at A and I go to B, I'm going to go over 1, 2, 3, 4 units. So I'm going to put a 4 right here. Again, and I'll show you with the marker. So if I start here, again, I'm going over 1, 2, 3, 4. That's how we got that 4. The same thing with a vertical line. So if I look at the length of line BC, so I'm going from B to C, since it's vertical, again, I can just count these squares it takes me to get from point B to point C. So if I start at B, I need to go up 1, 2, 3. So the distance from B to C, I'm going to put a 3. All right. Now, we need to find the length of AC. So if I have a diagonal line on my graph or on my coordinate plane, I can't just count the squares because the distance diagonally is not the same distance if I'm going horizontal or vertically. All right. However, if you look, we've created a right triangle. Here's my right angle right here, right? If I point an arrow going away from that right angle, that arrow points to my hypotenuse. Here, let's make our hypotenuse, let's make it red. All right, so here's my hypotenuse. That's what I want to find the distance of. Well, I know I can use the Pythagorean theorem, which is a squared plus b squared equals c squared. So remember, your hypotenuse is always going to be side C. That's the longest side in your right triangle. That's the side that's opposite your right angle. A and B, we'll just call this one A and this one B. It doesn't really matter as long as you have that hypotenuse labeled correctly. Okay, so we've got our hypotenuse labeled. We know legs A and we know legs B. So A was BC, which is 3. So 3 squared plus leg B, which is line AB, we said was 4. So 4 squared equals C squared. We don't know C. That's what we're trying to find. All right, so now let's do our math. 3 squared, or 3 times 3, is 9, plus 4 squared, which is 4 times 4, is 16, is equal to C squared. All right, now let's add 9 plus 16. We get 25 is equal to C squared. Now, we know what C squared is. C squared is 25, but we want to know what C is. So we need to do the opposite of squaring a number, which we know is taking the square root. So I need to take the square root of C squared. I need to take the square root of 25. So the square root of C squared leaves me with just a C. The square root of 25, I put that in my calculator, I get 5. All right, so this 5 is the distance from A to C. So if I go down here, the length of AC we know is 5, and we found that distance by using the Pythagorean theorem. So we plotted all 3 points on our graph. We connected the points to create our right triangle, and then we used the Pythagorean theorem to find the distance of our diagonal or our hypotenuse in that right triangle. So now that you've seen an example for this first one, I want you guys to go ahead and, on your copy that you've made, go to your second example and see if you can do the second example on your Google slide.